So in this video, I attempt to take this brand new CNC machine from China, tear it apart, and try to fix all of the issues that I didn't like. Will I succeed and have a magnificent machine in the end, or will I burn my shop to the ground? Let's find out. If you're a return viewer, welcome back to the channel. If this is your first time here, I appreciate the support. I made a previous video on this cheap CNC plasma machine that I purchased in China. So I left a link in that video, and a bunch of people have purchased them. A bunch of people like them. Some people had some problems, and I just want to state again, I'm not affiliated with them. I purchased this with my own money. Now, I have talked to the guy. He's really cool that sells these, and that's about as far as it goes. So I don't make money on these when you guys purchase these. That's not what this is about. This is just about me finding a cheap alternative to high-priced CNC plasma tables. If you guys didn't see the video about this cheap Chinese CNC machine with the link in the description, I'll leave a link to the video here, or you can go back, I think it's 2 videos ago, and go back and check that video out. So I want to address some of the issues that I feel this machine has and that some users have had that they've reached out to me with. The main issue is having to use their CAD CAM software and put the programs into their controller with their software. So there's really no way around that. I tried to make a post processor for Fusion 360 myself. I tried for like 3-4 days. It just wasn't happening because this takes a .txt file, where other plasma cutters and anything that uses like Mach 3 or something like that, they take G code. So it's really kind of difficult to do that. If I can make a post processor that would work just for this unit, then that would be the answer to everything. I wouldn't have to do this, what I'm doing right now. So if anybody out there knows how to make a post processor, let me know. Maybe we can hook up and you can make a post processor for this. We can skip this step right here. But for now, my answer is tear this apart, get into it, replace the board that's inside with a compatible Mach 3 board, because I built plasma cutters before, so I kind of know how to do it. I mean, I have the like $12, $15 Mach 3 board right here. I'm gonna use this. I'm gonna take his board out, and I'm gonna put that board back in, use Mach 3, and see if I can get it working on this machine. And then if I can get it working on this machine, what I'm gonna do is order a touchscreen that has Windows on it and mount the touchscreen to the top of this box. If everything goes as planned, that's the plan. But I don't know if it's gonna work. Let's open up the main controller box right here, take the case off this thing, make sure it works, and start going down the process of kind of reverse engineering this thing. So let me get it out of the box, let me get it set up, and we'll come back. I got it all wired up. Let's turn it on and make sure it works before we start tearing it apart. Hopefully you guys can see that. So there it is. Everything works. I can feel the servos as I hit those buttons, go forward and back. So I know that's all working. So my plan is to take this whole controller out of here and get inside the box, check out all the drivers, the board, how everything's set up inside of there. What I'm thinking will happen is I'll be able to take his control board out, replace it with my own control board that I can put Mach 3 on and start controlling it. This is actually a really cool unit. It's got a torch height controller built in. All of the servo drives are inside of this little box. It even has a converter that will convert from 220 to 120 inside this box. So this unit really has a lot built into it. And as I said, the easier way would be to just get a post processor that will work with Fusion 360 that I use, that will post process a .txt file to this machine. I've been completely unable to do that. Let's get this screen off here and see what's inside. Oh yeah, this is pretty crazy. Here's one of the little servos that moves the rack. Here's the other servo that moves the rack. And here's the control card in the back of the screen. So as you can see, this card is almost exactly the same as the card that I plan on using. Here's the pulse and direction. And on here it's the same. You see it's got P and it's got D, pulse and direction. So I just need to get these wires and figure out which ones in this ribbon cable are the pulse and direction, and tie them into this board, which messing with a ribbon cable is gonna kind of suck, but I think I can figure it out. And these, I assume, are maybe for the torch height controller here. Then here's the power wires coming in. You can see it has DC 24 volts. And there's some other stuff here. This is pretty cool how they have this all set up. So what I think I'm gonna do is disconnect all this and take this off so I can get into there deeper and just kind of figure out what everything is. So there's the controller off. Pretty cool unit. It's all built into here, has the control card in the back. Boom, top cover off. Now we can really see what's going on in here. Awesome. Wow, so this motor right here is actually on a spring to cold tension on that rack. That's really cool. Here's a power supply, 24 volt power supply. So it's crazy because they've like split stuff up. So here you can see this is the arc voltage. So this is the torch height controller section of it right here. The wire goes into here, and then this plasma on and off goes into there. So this is actually the relay also that tells the torch to fire. So we can take all this out of here and use this space. And here's the wires that go to the controller from there. So what I'll end up probably doing is taking this whole board out right here. And this is what I use to fire a torch. Now this has 2 outputs on it, and I do have one little one here that has 1 output on it. So I'll probably use those instead of this. And this is the torch height controller, so I'll get rid of that. This also leaves a lot of area in here if we need to add something. What's really crazy in this whole thing is the drivers for these little servos are all built onto one board, and it's one little small board. Never seen that before. Normally, they're bigger drivers. They're independent, and you have to wire them in independent. Like on this conversion I'm doing here, you can see I've got the same board, but this is a driver for these. These are actually servo motors, and these are stepper motors over here. So they're a little bit smaller, but I've never seen this. Check it out. So this is all the drivers for all 3 of these. This, and the torch control, the Z-axis, is built onto there. This board controls all of those. That's crazy. Like I said, since this is a ribbon cable, these are the outputs, the step and direction outputs for the motors that go to the control card right here. So since it's a ribbon cable, I'm gonna have to figure out which ones are which, but they should be in pairs. These are actually the power wires for these coming off of this board also. So I assume they run off 24 volts, so we're probably gonna have to keep that in there to move the drives. Pretty much everything I need is right here on the end, and I don't even need all this because, like I said, the torch height controller is not gonna work for us because the control is built into that controller. Let me separate some of these wires and figure out what I'm gonna keep and what I'm gonna use. I clipped a bunch of wire ties off so I could get everything kind of separated. And I think I've got my mind wrapped around what's going on in here. So let me show you what I got. So this is the Z-axis right here. This is the Y and Z axis, because you can see there's Y and Z axis right here. So I'm assuming this 24 volt power supply supplying the power to the stepper motors, which they have to because it's the only power supply in here. And on this board here, there's only 2 connections. There should be a third for the Z-axis, but here's all the wires for the Z-axis right here in this plug. And here's the Z-axis right here. So what I'm assuming is inside of this box, it must have its own little driver built into here. So we'll have to take this apart eventually and see what's going on inside of there. I know it has a limit switch inside of there. This is its whole own little computerized box, kind of standalone, which is pretty awesome. But pretty much everything stays the same in here. I take all this out, and if I can figure out how to get one of these to move, then of course I can get the others to move. I think for me to figure out what each wire actually is, the only way for me to do it is to actually cut the wires and do a continuity test. They do look labeled the same, like there's X on there, then there's X here, but they're just all different random stuff on these wires. And again, I don't see anything wrote on the board, so I guess we got to cut those wires. Okay, as a last ditch effort before I cut these wires to do continuity test, I actually took a picture of the board. I don't know if you guys can see it there. And really close to the board, you can see it says 5 volt positive, direction X, CPX, direction Y, CPY. And then there's J001, J007, and a ground. So I'm assuming 1, 2, 3, 4, 5. There's the 5 wires that we need to run into this board to get it to move this. We still have to cut these wires, but at least I have a blueprint to kind of guide me a little bit to see if we can get this to work. I'm into it now. I cut the ends off. There's no turning back now. What I'm going to do is use this kit. I'll leave a link to this in the description. I've had this for a while and I've never got a chance to use it, but this is one of those chances, and it has all these ends on it for wires like that. It has a bunch of different sizes, and then it comes with the actual crimping tool to crimp those, so I'm not just sticking direct wires into there and having them hanging out. So again, I'll leave a link in the description for all this stuff, the boards and everything that I got here, the plasma cutter that was only $150. I'll leave links down below for all this stuff. If you want to do this, it's all in there. This is the first time I've actually used any of these. It's pretty straightforward. So you just stick this on there, and then this thing just crimps it. So you put the metal piece in there, crimp it down. That's it. Nice solid connections. Nice. So what I've done after crimping those ends is I got the board here, right? And I just read the schematic from the picture that I took of the board of the wiring. And it says this first one is 5 volts. The second one is the X direction. And the third one is the X pulse. So if I'm reading that correct, that should be all we need. And what I did was just plug the board in. Now what I'm going to do, I don't know if you guys can see, but I'm going to pull up Mach 3 loader. I'm going to pull up plasma, and it detects that board that I have in there. I'm going to hit OK. So then you could see the light is blinking right now. I don't know if you guys can see that. See that? So now when I hit reset, sorry, it's pretty light in here, but when I hit reset, the light goes solid. So you know it's communicating. So now one of these, what do I have that in? X. So if I go left and right on the keyboard, it should move. So I also turned on the power to this device. So let's see if we hear anything. What? I don't know if you guys can hear it over my fans running, but oh man, it's moving. You see the gear down there? There it goes, one way and the other. No way. It was that easy, literally that easy to pull his board out and replace the board. Now, that part was easy so far, but like I said, I still have to wire in torch height controller. I have to tune these drives to this Mach 3 system. I have to wire in these relays so that the torch will fire. But that right there tells me if I can get one moving, I can get them all moving. I think there's a good chance that I can retrofit this with Mach 3. I mean, I pretty much just did it. So the next step is let me wire in this other stepper motor, make sure I have those wires correct in my mind, and see if we can get that moving. So if we can get that moving, from there we have to tear apart the Z-axis and get into here and find the board and driver for this and use the existing wire and wire into there so that we can get the board to communicate with that. But wow, I got it. I got it moving already. So let me get the other axis moving. Let's get this Z-axis tore apart and see what's inside of there. I just repeated the process and now I have the Y hooked up. So I've got the X and the Y working on this board. The gears will both move. I don't have anything dialed in yet. The next thing is let's figure out this Z-axis. So this is where, even though on here it says X, this is one of the weird things here. Like this says X, this is actually for the Z. So this is a whole self-contained unit. And this wires into this board in here. And this also has the limit switch in it, because this thing will go down and touch and give you your limit. So I have to figure out what wires are what on this. They do say ground 24 volts. And then they go into Chinese after that. Maybe I can decipher those, but if not, there should be a board just like this inside of here that we can zoom in on and see what the writing is. So let's get this taken apart. Okay, so I was completely wrong. There is no board inside of here. And this looks to me just like a regular DC motor. The wires come in there, they go down here. Here's the limit switch, so when this bottom thing hits, you can see it's hitting the switch. And that gives you your touch off. So now I'm a little confused. Because there's no other axis on this card right here. There's only the 2 axis on that card. And this has the ground, 24 volts and all that, but I'm kind of confused why there's no driver for the Z-axis. Unless the driver is built into this somehow, but I doubt it because that's just the control card on there. There's no driver inside of there. I'm not sure. Let me do a little more investigating and look this over a little more, and I'll get back to you. Well, after a lot of research, I found out you can control this motor up and down from this board without having a motor driver. So this is just a regular DC motor, as you can see there, just a cheapo DC motor. It's not a stepper or a servo motor. So really what they're using it for is just simple up and down. So it just goes up, goes down, and I think it triggers the limit. When it hits the limit, I think you just program it to come up for a certain amount of time and then turn off. And that's how they're getting around having another driver in this system. So I've been messing around with ChatGTP here, and what it's telling me is I basically need, from this board, I would use these output ports for Mach 3, and then I just happen to have these that I showed you guys earlier, and one of these relays would do the up, and one of these would do the down when this is triggered. So pretty much output 1 or output 2 is triggered, and when that's triggered, this will make it go up or down. And then what I think you do is wire in that limit switch right there, and whenever it hits that limit switch, it knows to stop and come back up a certain amount. And so I think you set that up in Mach 3. So I guess let me try to make some wires up and wire to this and then wire into that motor. Let's see what we get. Well, it's been about 3 hours and I've got a mess going on over here. But with the help of ChatGTP, I was actually able to figure this stuff out. It's crazy. I would have figured it out eventually with research. It probably honestly would have took me a day or 2 or 3 to figure this out with ChatGTP. Wow, man, this totally, and I'm not sponsored by them at all. Of course I'm not, but it really helped me. This is crazy. So let me show you what I got going on. Got everything tore apart here. So I pulled out the 24 volt power supply that was in there just so I could access it. I had to add wires. Got my control board hooked up. Here's the Z-axis. And since this is just a regular brush DC cheapo motor, it doesn't have a driver. You can't use a driver on it. It just straight up goes one way or the other as you tell it to. And so what I had to do to get this to work without having a driver and without having a stepper motor is, it's kind of crazy. It's kind of genius how they have it set up. I ended up using that board, that relay board that has the 2 relays on it. And I ended up using the outputs on my board, my control board. And Mach 3, actually, I had to configure those ports to be output ports and output 24 volt signal from those ports. And I had to use this 24 volt power supply, add 24 volts to my board, add 24 volts to these boards here, and the supply volts that go to the motor. Crazy. As you can see here, I've got just the spaghetti going on here, but at least I have all those connectors and nothing's touching. Don't have to worry about anything like that. But I have this figured out and moving. Let me show you how it moves here. So this is something called VB script window, which I never knew was inside of Mach 3. ChatGTP told me all this, and it actually gave me this script to put into here. And when you enter this in to output these, it just tells it, 2 tells it down, 1 tells it up. So pretty much 2 is just activating this one, 2 is activating this one. The 1000 is like 1 second. And here it goes, check it out. Boom. So if I want to reverse it, I just go in here and put 1, and then it should reverse. Wow, how crazy is it that I figured that out with ChatGTP? That is nuts, man. It literally codes and does everything. I didn't make this right here at all. I didn't write that. ChatGTP gave me that and told me to put it in there, the code, and it works. That's crazy. So now I figured out, by looking at it, I figured out how the Z-axis works. So pretty much it has 3 limit switches, 1 here, 1 at the bottom, and 1 at the top. So I have to wire in those limit switches to Mach 3 also to this board, so that when it hits one of those, you know, this will be the up travel. It'll tell you it's all the way up. This will tell you it's all the way down. And this is the probe. So that will actually be the probe. So when I wire that one in and click that, it clicks that, it'll know that that's the probe function. This is pretty crazy, man. Like the plasma cutters that I built, I actually went overboard, I guess, because I used stepper motors for the Z-axis and I used drivers. I guess you just don't need that type of resolution when you're only moving a plasma cutter up and down. I don't know exactly how the torch height controller is going to fit into this system and work with this system, but obviously it does because it works with it now. But we'll get into that. But I'm super stoked. So altogether, it looks like my plan's working out so far. All of this stuff fits back in here. This comes out. These two little boards can just wires cross over here, fit right inside of there, and just bolt them down or glue them down. Perfect. Put the case back on, it'll look totally stock. So far, so good. So now that I got it all figured out and know that I can get it to work, I'm going to order the tablet that has Windows in it so that I can use it with Mach 3. So I'll just have pretty much on here, what I plan on doing is just probably filling that in and just getting a 10-inch touchscreen right there and put that right over there, and then we'll be able to just use it as a touchscreen. And then I'll also get one of those little wireless keyboards. They're real little, fit in the palm of your hand. They're like 10 bucks. And then you could type stuff and move it around and do all that. So I still have to get into the settings and configure Z up and Z down with these two right here, these two inputs. So I'll have to do that and figure that out. So that's not going to be the easiest. But with ChatGPT, might not be that hard, to be honest. So the next thing on the list is I have to do that. I want to get all that set up and programmed so I can hit up or down and the Z-axis will move up and down until I let go. And then I have to figure out how to wire in all of these limit switches. So let me dive back in, see what I can figure out with that stuff, and I'll bring you back. Let me tell you guys, getting this thing to work has been crazy. Getting it to go up and down correctly, and then getting this limit switch right here to work and actually go up and down and wiring all that in and getting these custom macros to work in Mach 3 has been crazy. I thought it was going to be pretty easy once I got it kind of moving with the macros in the Mach 3, but no, it's been probably 8 hours today and about 6 hours yesterday to where I got the up and down working with the 9 and 3 keys, and then then I got the probe working, but then the 9 and 3 keys wouldn't work, and I had to go all the way back and start from scratch again. Without ChatGPT, I can't stress it enough, I could not have done this. I created custom macros to make the number 9 and 3 key the Z up and down, and then I also created custom macros to make this limit switch a probe and to tell it how far to come back up after it probes off. It's been crazy, but I have it figured out. And how this works is these two limit switches that are in here are directly wired to the power on the motor, so they don't need to be connected to the board at all. Just when this goes in the up direction, it hits this one, it stops. It goes down direction, it hits this one, it stops. It just can't go any further. That's how it works. This I had to configure as a probe and had to find those wires and get them into here and get them working. So this actually probes. So it's crazy. So it's a custom macro, long story short, that I had to make, that when I enter certain commands on here, it tells it to go down, it tells it to probe, and it just works. So it works now. I don't know how the post processor for Mach 3 is actually going to work for that system to probe. I don't know if I'm going to have to configure that to work with the M200 command that I'm using for this to go down and probe. We haven't got that far. We'll get there when we get there with that part. I don't think that'll be too hard to figure out, but let me show you how this thing works, because I put a lot of work and a lot of effort into this. Blood, sweat, and tears went into this. Let me show you how it works. So here's the Z-axis. Now I have it configured. When I hit the 9, it goes up, and the 3, it goes down. So you can see there, the 3 went down, the 9 goes up. So then when I go to MDI in here, boom, and I type in M200 and I hit enter, what it does, it goes down until the probe is triggered, and then it goes back up about a ½ an inch. So let me trigger it, and then we'll hit the switch. Boom, and then there it goes up. So how it works is when you put your plasma torch in there, it's going to go down, until it hits that probe. So it's going to probe, and then it's going to come back up to a desired position that you set. So you have to kind of, I'm going to have to figure that out, how far up it goes, and I can just get into the root file and kind of change it. It's really easy to figure that part out. So as of right now, I have it all working. I can start bolting stuff back up. I actually got the laptop in for this. I should have the mount for it tomorrow, and we can get it on a rail and start testing these things out and get to the next level of this build. So it hasn't been as easy as I thought it was going to be. I knew this was some really custom stuff that had to be done with these macros and stuff, because I've never messed with anything like that before, but I'm getting it. So that being said, I guess I'm going to button this back up since I have everything working on that. I'm going to start, I have to extend these wires a little bit to get them over there securely, run everything through there, do everything real nice. I'm going to mount this and this. The next thing I have to do also is figure out how to get the torch to fire once I get into that with the plasma cutter. And I'm going to have to use that other little board that I have and mount that in there somewhere. So that's going to be a separate thing that I have to figure out, but that's pretty easy. Actually, I need to make a cover for this right here. And then I'm going to put a mount on here, a little tiny kind of ram mount to mount the 12-inch pad that I got on there so it can swivel, turn sideways, and you can use it sideways. That's one of the things I kind of didn't like about the other one. It's facing like this, so when it's being used, it's actually like this on the rail, and you have to kind of come over here and see from the side. I like that I'll be able to turn that pad sideways and use it, so I think that's a major upgrade. So for now, let me actually start making this plate for this, get that painted, and then I'm gonna get all this stuff buttoned back up, and then we'll move on to the next step. Let me catch you guys up on the progress I made. I've got it mounted on these metal sawhorses from Harbor Freight, nice and sturdy. I got the Y-axis rail on. I got the X-axis rail on. I got this cover plate made out of aluminum. What I'm gonna do is when the mount comes in, I'm just gonna bolt it right to that, and then I'll be able to swivel the tablet. I also transferred all the information that I have in here for Mach 3 to this Microsoft Surface tablet. It's a Microsoft Surface Pro 12-inch tablet. So everything is identical inside of here. So it's all touchscreen. You can go through all the screens here, do whatever you need to do. And it did come with this magnetic keyboard, but I took it off. And I actually use this. So you can see when you want to run it, just hit that. And this jog key should take care of everything. Check it out. How crazy is that? Wow, nice and smooth too, man. Actually way smoother than the controls that were on there. So then for the Z-axis, this doesn't have a number pad, and I had it programmed for the number pad, so I actually had to transfer it to the page up and page down. So now you see when I hit page up and page down. Super, super nice. Getting to this point has made me really, really excited about this project again. At this point of the upgrade, I feel this rivals any $4,000, $5,000, $6,000, $7,000, $8,000 plasma machine that you can get out there. This has a touchscreen that has modern Mach 3 inside of it that you can use Fusion 360 or Sheet Cam or anything else with. The controls are nice and smooth. It comes with a wireless controller, which most CNC machines you buy on the market don't. It comes with a plasma cutter. So at this point, while I'm waiting on this mount for the pad, what I have to do is wire in the plasma cutter and this little relay right here. And this relay will tell the torch to fire. So I do have to take the top of the box back off, so it's not a big deal that I didn't get the mount in yet. Then after that, I'll get it all re-put back together. So I won't bore you with that. I'll kind of bring you back after I get all this done and show you how we get the torch firing. Okay guys, after a lot of time and a lot of effort, I finally got it complete, and I cannot wait to show it to you guys. It's awesome. Before I do, I just want to let you know I will be selling this machine. This machine will be for sale in a link below or in my support store below. What I'm including with that sale is free shipping, touchscreen laptop, the plasma cutter, the wireless keyboard, and at that price, it's still priced way below any machine that has a 5 foot by 3.5 foot cutting radius. And I also want to say, if you guys have the old machine and you want me to do this retrofit for you, you can send your box in and I'll charge you a small fee, and I'll do that for you. You can just email me below, prestigemanufacturingky@gmail.com. Let me know you have a machine. You can send just the box in, and I can do all this stuff for you, send it back out, and you'll be ready to go. So after all that, let's check it out. Here it is, totally assembled. You see I got the touch screen on here. I got Mach 3 running on the screen. I got a lot of sun coming through this building, so I hope you can see it good with the glare. But you can move this around however you want. I got it turned sideways, which is awesome because now you can stand on the side of the machine and use it as opposed to hanging over and kind of doing that. You can turn it all the way if you want. I have everything enclosed in here, wired up perfect. Painted the front panel here. I've got the torch wired up, and here's the back side. So it's still portable. You can unplug everything, just lift it up. This touchscreen tablet will come right off of there. You can just store that away if you want. And here's a brand new plasma cutter. This will cut up to a 1/2 inch. It'll do 110 and 220. It's just crazy how much more user-friendly this machine is with this tablet on here, running Mach 3, and I was able to actually tune the drives and dial everything in myself. It's insane. So here's my part in Fusion 360, just a little bracket that I made. We can go back up here and check it out in the design, and then come back down to manufacture. And then here's my cut file. What I did was post-process out that cut file with my custom-made post-processor for Mach 3 for this machine. And then I brought it over here into the stick. Boom, I loaded it up. And then on Mach 3 right here under the screen, you can see it, if you can see it. You see it there? So then what I do from there is I use the wireless control. And I go somewhere that I want it to cut, let's see. I think that's good right there. And then I zero all my axis, hit cycle start, ready to cut. And it moves super fast. I don't know if you guys can tell, but look how fast it moves compared to what it moved before. Boom. There's a piece, drop right out. Boom, look at that cut quality. Now I didn't dial any settings in or anything. This is just me running this right out of the box. I didn't dial in like the speeds and feeds or anything. I just used speeds and feeds I had before in there from a plasma cutter table that I had built. And check out that. Now there's a little bit of dross on the back, which will knock right off, which is very common with a plasma, but I can dial it in to where it goes faster. It actually needs to move faster and get rid of a lot of that dross. But the main thing is look at the circles and look at how good it did in the cutting. And I measured everything corner to corner because I cut one already, as you can tell, and everything's spot on. So what I didn't do with this one for a couple reasons is I didn't put a torch height controller on this, which I can add really easy. But one main thing, it's the cost. So it's like $275 to get a little torch height controller. And then you have to pay another $175 for the all access Mach 3 so that you can use a torch height controller. So I can add that if someone wants to add it, if you guys want to add it. But for me, it probes each cut, and the plasma cutter itself actually has a drag tip on there. So you're supposed to drag it anyway. So if it comes down and drags a little bit, it's fine with me. And you can see my setup, it's kind of janky. I just have it on saw horses. It's not level or anything, and it cuts just fine. There's no problem. So for me, usually when I'm using the plasma tables, I usually turn that off anyway because it causes a lot of problems. But yeah, that's it. What do you guys think? It was a lot of work. It was a lot of time. I think it was worth it in the end. This is still killing any machine with this cut radius, and you get a plasma cutter with it and everything's ready to run. I don't think you can beat it for this price. So was it worth it? Let me know in the comments below. Again, if you're interested in purchasing this machine, I'll leave a link in the description, and you can go to my support store below this video and you should see it for sale there. If this sells and you guys are interested in another one, message me. I'll let you know when another one's done, because if this one sells, I'll immediately order 1 or 2 more, and I'll do the same thing to those and I'll put them back up for sale. So again, thanks for the support. I really appreciate it. If you haven't, give me a like, give me a thumbs up, follow the channel, be on the lookout for the next build.